Okay, let's do another example similar to the last one. We're trying to graph a polynomial function, and we're going to follow the five-step process that we laid out in the previous video. So the first step is to find the x-intercepts, which just means to set y equal to 0. So we have negative x plus 1 times x plus 3 times x minus 4 squared equal to 0. And in the last video, it took a lot of work to solve this equation because the function was given in standard form and we had to factor it. We had to use a synthetic division. We had to find possible rational zeros and then use synthetic division. This time the problem is a lot easier because we're given the factored form, and so we can get the answer straight away. So we can just take each factor and set it equal to 0. And let's see here, we'll have x plus 1 equals 0 gives us x equal negative 1. X plus 3 equals 0 gives us x equal negative 3. And x minus 4 equals 0 gives us x equals 4. So we can write those as ordered pairs. And then the other thing we want to do is talk about the behavior at each of the x-intercepts. Since the exponent on x plus 1 is 1, then we know that's a cross. Same for x plus 3. We know we have a cross there. But x minus 4 is different. The exponent is 2, and so that means that the graph will bounce off of the x-intercept. So we'll get to see that when we sketch the graph in a few minutes. Okay, step 2 is to find the y-intercept. And so we're going to set x equal to 0. We're going to do g of 0 is equal to, we need to be careful here that we don't make a careless mistake. I like to show the substitution every time. 0 plus 1. See, I already made a little mistake here. Let's see if I can fix that. That is not a 0 up front. That's just a minus sign. So now I think I have it. I have g of 0 is equal to negative 0 plus 1 times 0 plus 3 times 0 minus 4 squared. And then this is 1 times 3 times negative 4 squared is positive 16. So 3 times 16 is 48 with a negative in front, negative 48. And so we can go ahead and write 0 comma negative 48. Okay, step 3 is the end behavior. And we need to look at the leading term. Well, we don't see the leading term straight away because we have this factored form. If we want the leading term, then we need to have standard form. So we need to multiply all these factors out to get standard form. But we don't really have to do all of that because all we need is the first term out of standard form. So if we just multiply the highest power of x from each factor, then we should be fine. So this is x to the first power multiplied by x to the first power. That's x to the second. And then you have x to the second here. X to the second times x to the second is x to the fourth. And don't forget that negative sign in front. So the end behavior is like negative x to the fourth, which means that we're going to point down at the left and the right ends of the graph. Okay, step 4 is the sine diagram. And so let's see here. We need columns for interval and test value and sine of g of x. And then finally, is the graph above or below the x-axis? That's a little question mark at the end. Okay, so let's make some columns and some rows. Let's see here. We have 3 x-intercepts, so we're going to use those to form our intervals, right? That's where the sign of the function can change, is at an x-intercept. And so if there are 3 x-intercepts, then there will wind up being 4 intervals. We're trying to account for the entire domain of the function, which is all real numbers. So we need to start from negative infinity and go up to the first x-intercept, which is at negative 3. From left to right, negative 3 is the first x-intercept, then negative 1 is the next one. And then negative 1 to 4, and then beyond 4 all the way out to infinity, the sign will be the same. And then we can do test values, so pick a number between negative infinity and negative 3, and so on for each of the intervals. And then the sine, so we'll get the sine of g of x by plugging negative 4 into the original function. Now we've got to be a little bit careful because there's a couple of tricky things going on here. So first of all, there's a negative sign out in front. So let's write that down. And then we have negative 4 plus 1, which is a negative. And then we have negative 4 plus 3, which is a negative. And then we have negative 4 minus 4, which is a negative, and it's actually squared. So we could write it out twice, or you see I have a little notation here for the negative squared. How many negatives are getting multiplied together? Looks like 1, 2, 3, and then 2 more makes 5. So 5 negative numbers multiplied together gives us a negative. An odd number of negatives multiplied together gives a negative. An even number of negatives multiplied together gives a positive. Okay, so for negative 2, we'll go just the same way. We'll start with the negative out in front, and then we'll do negative 2 plus 1 is a negative number. And then we'll do negative 2 plus 3 is a positive number. And then we'll do negative 2 minus 4 as a negative, getting squared. So how many negatives are there this time? 1, 2, and then 2 more. That's 4 negatives multiplied together make a positive, times that last positive number will stay positive. A couple more times. Maybe you want to stop the video and try to check these signs for yourself. I won't spend too much time explaining it. Okay, so we have a negative 0 plus 1, 0 plus 3, 0 minus 4 squared. 3 negatives together, multiplied together, are going to give us a negative. And then 5 is going to give us a negative, a positive, another positive, and a positive squared, and that's going to give us a negative. So we can go ahead and say that the graph is below the x-axis most of the time. since g of x is negative, since the y values are negative, the function is below the x-axis. When the y values are positive, the function is above the x-axis. Okay, let's try to put it all together here in step 5 with the graph. And so let's draw some axes and let's label them. And then we just want to plot the x-intercepts. So you have an x-intercept at -1. And also at -3. And then you have another x-intercept at 4. Okay. You also have a y-intercept, which is going to be down at -48. We don't have to go too far down. We don't have to have the scale be the same on the y-axis as the x-axis. So we can put our y-intercept somewhere here that looks convenient, and we can call that -48. And then what I'd like to do now is I'd like to start with the end behavior, and I'd like to not use the sign diagram. It turns out the sign diagram has good information, but it's redundant. We don't actually need the sign diagram to get the answer. So let's just focus on what we know in steps 1, 2, and 3. Make the graph, and then we'll look back at the sign diagram, and we'll see that the sign diagram and the graph agree with each other. Okay, so let me show you what I mean. So the end behavior, at the left end of the graph points down. At the left end of the graph, y values are going down to -infinity. So I've got this arrow pointed down to start. And then from there, I'm just going to connect this arrow through the points that are already plotted, the x-intercepts and the y-intercept. And I'm going to use the behavior at the x-intercepts to help me. So first thing I need to do with this arrow is I need to come up to -3, 0. And then we know that we have to cross over the x-axis to the other side. So let's do that. So let's cross over to the other side of the x-axis. And then we need to start coming back down to get to the next x-intercept at -1. So, and furthermore, we're going to cross there. So I'm going to continue the graph through the next x-intercept. I'm going to cross back over the x-axis. And then I need to catch the y-intercept at -48. And then I just need to head back up toward the last x-intercept at 4. And I have to be careful here because this one is a bounce. It's not a cross. And so I need to draw the bouncing behavior. So we have the bouncing behavior. And our graph is finished and it's correct. And we didn't need the sign diagram. Now we can go back and check that the sign diagram looks okay. The sign diagram says to the left of -3, the graph is below the x-axis, and sure enough it is. And then above the x-axis, from -3 to -1, there it is above. And then below everywhere else, from -1 to 4, and then from 4 to infinity. Of course, at 4, we're right at the x-intercept. So we're not actually below, we're on the x-axis at 4. Okay, I hope this helps. We'll have one more video and we'll be finished with section 3.4.